something to think about over the weekend. We're in charge of ordering programs for St. John Fisher College football games. That said, because of the time it takes to print the orders, we have to get this order to the printer by July 30th. That said, we don't want to waste money printing programs that don't get used. So, it is July 30th, and we need to make a forecast. So the question is, given it's July 30th, what can we put into a regression model that we can use to forecast attendance? Now, of course, we are going to use the actual attendance for past football games. So, what besides that? Yes?
Day or night? So I guess
time of day. Time of day is one of those interesting ones because putting it into a regression model, well, we'll talk about how to do that in about 10 minutes. That said, yes, you can use time of day, whether or not it's early morning, because early morning people are still trying to get up. If it's late at night, people have other things to do. But if it's in the afternoon, chances are we might have a lot of people. Yes.
Who they're playing? If it's like a big game versus like a big game.
Oh, there's a lot to do with the opponent. In fact, a lot of what we will use deals with the opponent. Now, you said big game. So first of all, conference, right? Whether or not it's a conference game. Second, whether or not it's a local game, right? For instance, Courage Bowl, right? Yeah, when I first came up with this example, it shocked me that Nazareth and RIT didn't have football teams. So I just put local to represent that. There are other things we'll look at with regard to opponent, but just a minute. Yes?
Chance of success, like if they're going to win or not. I'm more likely to go to the game if they're going to win than if they're going to lose.
Okay. Here's the fun question, and there is an answer to this. How do you represent it within a regression model?
I don't know.
Well, here's a question. Suppose we're playing University of Wisconsin-Whitewater. You understand. What are our chances of success there?
Like 0.
Well, yeah, basically. Mary Hardin-Baylor, for instance. Let's see. Oh, Mount Union. Yeah, and yes, it was. It was. Well, part of me kind of wishes I could have been there.
Yeah.
Because, well, not just because of the game, but because, well, I have family who live in Austin.
Oh, yeah.
So, yeah, Belton isn't that far from the Austin area. But anyway, conference, local, opponent ranking. We deal with preseason ranking, but yes.
Weather.
Weather. Now, here's the fun question. It's July 30th. How do we represent this?
Can you do like rain or no rain?
Rain or no rain, that's kind of difficult to do at this point, but there are things we can do. The game's in early September. What do we expect the weather to be?
Cold. Warm.
Fairly warm by comparison, yes.
September.
That's it. You're probably about 15 seconds ahead, right? Yeah. On the other hand, if it's late November, what do we expect?
Cold.
Yeah. So what we can do is we can represent that as a time variable, specifically what week the game occurs in, whether it's week 1, week 2, week 3, week 8, week 10. There's a reason why I represent it as week, and that's because, well, when I was trying to find this data, guess what I found? Week. Any other ideas?
The day of the week, Friday, Saturday.
Well, day of the week is kind of interesting because do we have games outside of Saturday?
I was going to ask that. All right.
Yeah, might be a good one to put. If it's a factor. Yeah, the question is it a factor? There is one other thing within an opponent that might be interesting. Who do we play with regard to an opponent?
close, they can bring fans to their place.
So distance, so let's put that. But there is one other issue. Suppose we're playing Buffalo State. What's their, well, how much, how many people go to Buffalo State at, enrollment? About 11,000, right? By comparison, suppose we're playing Mount Ida. About how many people go to Mount Ida? Only about 1,300, but you see that there's a range here, right? So perhaps opponent enrollment needs to be put into the model. Are there any other ideas? I think I've got a pretty good list. One other thing that I put in my model was what year it was, whether it was 2004, 2005, 2006, and that'll cause us some issues, but we'll get to that later. Any other thoughts? Well, I do think we have a pretty good list with, yes?
Maybe like how, like what our team is projected to be, how well they're supposed to be.
Our ranking,
really good.
okay. Now keep in mind, the rankings we would use would be preseason, because when it comes to all of this, this is occurring at July 30th. So it's in this case we don't have, say, the rankings during the season, but we do have the preseason rankings. So we have a list of various things that we could put into a forecasting mode. Now, here's the fun question. And the reason why I ask this is because, well, actually I'll ask it in about 2 minutes. So, what I'm about to do is, well, how many of you watch cooking shows? Okay. What generally happens within a cooking show?
I don't know what you mean.
Well, here's the thing. They cook. They prepare a dish, right? They prepare some item to, of course, be eaten. So what happens then? They take it out of the oven because they already cooked it. Now, the reason why I point this out is because we have all of this data that we need to gather. So how long will it take to gather? Well, it'll take a while. In this case, I had to go to each game log, look at, okay, what week was it? What was the attendance? Who was the opponent? And then, of course, once I knew the opponent, I had to go and look up things like what's their enrollment and things like that. So finding this data in all of these different sources takes time. So, well, we've figured out some things that we can put in our model. So now it's time to take it out of the oven. So we have our data. And here's what I put in my model. Again, your result may vary. I put, of course, we have to put in attendance because this is our y variable. And, unless we have a judgmental forecast, we're going to need past attendance to form our data, form our model. I put what week it was, week 1, week 2, week 3, week 5, week 10, for instance. I put whether or not it was a conference game, whether it was an Empire 8 game. I'm here, and put that as a 0-1 dummy variable. I put whether or not it's a local game. And like I said, at the time I came up with this model, I didn't realize that RIT or Nazareth didn't have football teams, so whenever they played Rochester, well, Courage Bowl. And then I put the opponent enrollment, and then I put what year it occurred. So I put this into my model. So what next? Well, next you have to make sure that you have data analysis set up. So what you do to make sure you have data analysis set up, if you don't have this nice little button here under data, click on File, Options, Well, this comes up. So you click on Add-ins, and you click on Manage Excel Add-ins. Click Go. And you'll see that there's options for the add-ins. Well, click on Analysis Toolpack to make sure that you have data analysis available. So, for data analysis, well, there's a bunch of different things available, all sorts of different tools available. What you want is regression. So you click on regression, click OK, and you select your Y range. And you'll note Y range, it's always a good idea to put labels on top. Reason why is because when the data is processed, you want it to make sense. You want the data to have meaning. So we make sure to put labels on top. So we have Y range of, that's attendance, that's what we're trying to forecast. Now we select our X range. These are the X variables. These are what we plan to put in our model. And again, make sure you have labels selected. You click OK. And this is what comes out as a result. This is what's known as an ANOVA report. And it's important to look at a few things here. First, we look at statistics, and we see that with an R squared, that means that 55% of the variation within our results is explained by the model. So our model explains about 55% of what's going on. Now the other important parts, well, let's see, you have standard error, standard deviation of about 11.7. Other things to note, right here and right here. Now, the first thing to note is the coefficients themselves. This is our model. This part right here is our model. So what is our model? Well, Y, attendance, is equal to negative 36,520, roughly, plus negative 54.7 times week, plus 1126 times conference, plus 4,003 times local, plus basically 0 times opponent enrollment, plus 19.2 times so, is this a good model? Make sense? Not exactly. So, how much does it make sense to have attendance of negative 36,500? Yeah, there's some issues with this model, and we'll talk about a few of those. The first actually lies with the year. To understand what's going on with the year, it's important to know what is happening within this model and how we use it. So we have 2009 for our year. So we put in 2009 times 20. 2009 times 19. What's 2009 times 19, roughly? Well, it's about 38,000, right? So, guess what's happening with this? Most of that negative 36,000 is because we put year as 2000 something. In general, what's a good idea to do for the year is to change the data, transform the data. So instead of using 2004, 2005, 2006, use year 1, year 2, year 3. It makes the data make a lot more sense. That said, there are other issues. And to explain what we do next, I need to explain something. Or more to the point, ask a question. Do we want a model that is as complex as possible? No. There's a very good reason why. I I mentioned before about the sources of variation. You know, things like trend, seasonality, like irregular variation. But then there was this last one, random variation. Random variation is one of those things that can cause some interesting effects. What tends to happen is that the more complex a model we make, the more we end up trying to forecast this random variation. Here's the thing. You can't forecast random variation. So what ends up happening? We try to make a model more complex. Well, the more complexity we put, we start having some gains, if you will, in accuracy. But those gains tail off over time. Now, it's important to note what's going on here. This is existing data. This is how well our data, our model, matches the data we already have, the data we're using to come up with the model. On the other hand, what ends up happening is what we're trying to forecast, which is the point of this model. The more complex we get, after a while, the less accurate it becomes. So, a little complexity early on is good, but after a while, the more complex the model you make it, the less accurate it becomes. And the reason why is because you end up trying to forecast this random variation, and it doesn't work. So what we want is we want a model just complex enough to explain what's going on without trying to forecast this random variation. So what we need to do is we need to start eliminating variables. We need to start simplifying this model. So what we do is we look for whichever of these variables. Now we leave the intercept alone because that's a y-intercept. That's not a variable. So we leave the y-intercept alone, but we look at the other p-values here. The p-values for these other variables. And we see which of these is largest. Whichever one is largest, we eliminate. In this case, opponent enrollment, because it's got a p-value of 99%, which means it's basically 0. So we eliminate opponent enrollment from our model and run the data again. Now, there is one other thing I need to point out, and that's this bit right here. 3.12e negative 0.5. Sometimes you see numbers presented in Excel in this format. What this means is that it's either a very large number or a very small number. If that's a positive 0.5, it'd be a very large number. It would be basically 312,000. But if it's a negative 0.5, this represents 3.12 times 10 to the negative 5. Or, write it out, 0.000031. So when you see number e negative something, it's a small number. So basically 5 decimal places away. So that's what's meant when you see that notation. Just be aware of it, because you might see it when it comes to these models. So, we have opponent enrollment, which we're going to eliminate. So we remove this data from our model, and we run the data again. So now we have, and we've eliminated opponent enrollment from our data set, and we run the regression again. So, click on analysis, regression. Make sure the labels are there. And, well, let's see what we have. We haven't lost anything with regard to the R squared, basically, because that's still about 55%. And the data's still not making so much sense. You know, it's negative 36,000 for the intercept. But we still have p-values that are greater than 0.05. If we have all p-values that are less than 0.05, it means that all the variables are significant. It means, hey, we have a model that works. All the variables in it work. But we have p-values that are greater than 0.05. That's what we look for. If, other than the intercept, there is a p-value greater than 0.05, we need to eliminate that variable. So, we take a look at these and we see which one's largest. In this case, year is largest. So, we eliminate year from our model. And we run the data again. So, run a regression model. And now it's starting to be clear. Let's take a look at this model as is. So y equals 1,912 minus 53 times week plus 1114 times conference plus 4,007 times local. So let's think about this model for a minute. If it's just your random ordinary game, does 1,900 people coming to it sound about right? Oh, yeah. The further on into the semester we go, there's about 50 less people because of the weather each week. Sound about right? Well, all you have to do to figure that out is go outside. So yes. For a conference game, there's about 1,100 more people. Sound about right because it's a conference game. So in total, about close to 3,000 people at a conference game. Well, yeah, it sounds about right. And then for the local game, for Courage Bowl, there's about 6,000 people. Sound about right? Well, yeah. So, does the model make sense? Yeah. That said, can we improve our model a little bit? You know, maybe refine it a little bit by removing one more variable. Well, go ahead.
Oh, I was going to say remove week because it's above 0.05.
Exactly. So, we eliminate week from our model. And you realize, okay, we have a pretty basic model here. We just have whether or not it's a conference game, whether or not it's a local game. But here's the thing. Does it work? Well, let's see. So we run the data one more time. And we have our data analysis, regression. And we get this model here. Now the first thing we note is that all the p-values are less than 0.05. So all the variables are significant. All the variables matter. So here's our model. Y is equal to 1,714 plus 949 times conference plus 4,062 times local. So let's think about this. For just your average run-of-the-mill game, does 1,700 people sound about right? Well, yeah. For a conference game, Empire 8, there's about 2,600 people. 1,700 plus 900 sound about right? Well, yeah. For Courage Bowl, there's about 5,700 people. 1,700 plus 4,000 sound about right? Well, yeah. We have a model that works. All the p-values are less than 0.05. So we have a model we can use and a model that we can stick with. So we have our model, we can then use this to forecast the attendance for games going forward.